1, 2. Okay. Okay, let's start. You can ask questions either in YouTube chat or in chat here in MS Teams, and yes, you may also use your voice in MS Teams if I can hear it. Okay. Okay, everything apparently works. If there are any technical problems, let me know. Okay, so the next assignment or next exercise we will do is Hough transform. Okay, you did Hough transform for your labs, so in theory this shouldn't be too difficult. Now the problem is that still I find often that it is still very difficult, which makes me wonder what did you do for your labs. So we will do an example here. Okay, this is actual example from the actual exam. Okay, so you see you will get something like this. So I will plot this on the whiteboard. So don't think that you have to read this, but what you will get is the image. Yeah, you see the image here, and you will get you will get accumulator here. Okay, so what we give you is already defined size of the accumulator. Otherwise, it's very difficult to solve this properly. Okay, so calculate transform for lines for the following image. So let's say following binary image, okay? So there won't be any misunderstanding. We'll clearly say that this is binary image. So this is binary image I, okay? And what is important, you will be given the direction of the coordinate axis and also accurate coordinates of the rows, okay? So this will take some time, so you have time to draw this at home as well. So here there will be image, yeah, and let's do it like this. So here we have x coordinate, yeah, okay, I need some more space here. So here we have x coordinate, and here we have y coordinate, okay? Yes, it could be seen. Good. So here we have rows. Sorry, columns. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, whoa, 15. Oh, perfect. And here we have columns. Sorry. Here were the columns. Here we have rows now. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Still fits. Okay. So, like this. I'm doing it on purpose on the whiteboard so you can follow me, yeah? So I could show you this in a projection, but then, I mean, you wouldn't have time to do it properly. So. Okay, so then let's draw this like this. Okay, some professors are famous for drawing perfect images on the blackboard. I'm not one of them. Okay, so, but I think still pretty good. So, okay. One important thing is that usually during the exams, when you have exams at the university, you can also solve part of the problem here. Now, because you will be doing this from home, you'll have to draw everything on the piece of paper. So that's why we're trying to do it this way as well, okay? You won't have a printed out piece of paper at home, or at least I won't require this from you. So let's practice drawing straight lines for a while, okay? And yes, if you have any paper that has already squares, Mali Caro, yeah, then this would be good for solving the exam at home, okay? Of course, here the pixels grow larger just because I need more space to do it. Okay, so this is our input image. This is what you get. And okay, we have those pixels that have positive values. So we'll say, okay, this, and then it's at 4. And I think, no, 0. Oh, I made a mistake. Sorry. Before you mess up your drawing, I will stop. It's not actually here. Okay, so we have here at coordinate 2, 2 is the first pixel. Okay, and 4, 2 is the second pixel. And then we have 4, 2, 4, yeah. So here is the third positive pixel. And then, okay, and then at 4, 4 is the next one. Okay, so, and we'll just add a legend here. So this is 0 value, and this is let's say positive pixel. Okay, which is 1. Okay, so this is something that you would ordinarily get. Okay, this is really big, but okay. This is something that you would get on the piece of paper, and you wouldn't need to copy it in the normal circumstances. Now, maybe if it's also good that during the exam you don't try to copy, so you don't do such mistakes as I did. Yeah, I will try to make the exam fit on a single screen if possible, so you wouldn't need to scroll. Okay, so you could just look at the screen and look at this at the exam. Okay, so this is my intention, to provide you with the PDF. You just maximize on your screen, and then you just look at it. Okay. So this is one thing you get, and the other thing you get in such kind of a task is accumulator space, H. Yeah. So let's say H, and of course, let's say here we need to add something. Where? So let's say use line equation. Line equation sorry okay, so this equation, you will use this equation, the simple form. I won't give you the that row theta form. We don't do this on the paper. We actually didn't do it in the labs as well. Okay, so this equation, so now our Hough accumulator, and this is also something that you get. So now Hough space accumulator will of course have coordinates k and n. Okay, and let's do it like this. Yeah, I want to try to fit this into single screen, and we will do the calculation on the other side then. Okay, so our Hough accumulator will then be like this. Okay, this would be more difficult, but I'll try to draw it. So, and it will be, so it will be like this. And we will have two axes. This is something that you already have in your in the task. So here it will be K, and here it will be N. And this is very important. Yeah, we give you this so you know how to construct a Hough accumulator. Yeah, so there is no issue. What should be the range? What should be the granularity, and so on. So okay, and here we have then, yeah. Okay, I'll have to start like this. So this will be -3, and then another section. 1, 2, 3. The fourth one will be -2. Yeah, and then we have one empty, yeah, and will be -1, and then another empty row. Sorry, -1, and then this is 0 here. Yeah. So 1, another empty row, 2. Okay. 3. Empty column, sorry. This is now 4, and this is the end of the accumulator. Okay. So we will draw it like this. Yeah. And so I'll draw the vertical lines. This is something you will have to copy in your exam if you want to solve the this task. This one is pretty bad. Okay, so let's do it better. Yeah, perfect. Okay, so here the K, you see the K values are negative, and this is something that is expected. And also the N values will be negative. So we will start it. This is constructed properly, this accumulator, so you can solve this image. Yeah. So if you have different kind of image with different coordinates, then we would give you different boundaries of the accumulator. Yeah. So let's start here. So the first value is -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Wow, that 8 does not fit on the image. Okay, so I will try to compress them a little bit. Yeah, so okay, stupid. -1, so here comes 0, 1, 2, 3, 4, 5, 6, 7, and 8. Good. So this will be the end of the accumulator here, and I will also draw the horizontal lines now. Yeah, it will be a bit wobbly, but we can live with it. So yes, square pattern paper will be good for this, okay? So you can see what I'm doing. Okay, I will fix this. Extend a bit this thing. Yeah, so 7th row will be here like this. Yeah, and then we will add 8th row. Hopefully this one wouldn't matter, but I think I have a sense that it will, if I remember that one exactly. So apologies for this. Okay, and now just a second. I will change the angle of the camera. Just a second. Okay, this should be better, but okay, I'm just changing the source code of the application I have here. Good. Okay, so this is stuff of embedded systems. So next year or next semester. So now here, this is an accumulator, okay? So what you're gonna do in this side, you'll have to accumulate numbers, okay? So please use something, some kind of a pen that you can erase on this side, okay? And then when you're done, go over it with the permanent pen, okay? So for Slovenian students, uporabite navadni svinčnik in redirko. Zato potem na koncu pa obvezno prevlečite rešitev z permanentnim svinčnikom. Okay? Now, the exam itself would look like this. You will take a picture of your resulting pages, yeah? The things that you will write down. And of course, for this to be clearly visible, you need to have the exams, the results written down in permanent, with permanent pen, like ballpoint pen, blue one, yeah, or something like this. Otherwise, it won't be visible on the pictures that you will take. But in this case, you will see at the end I will have my fingers black because I will have to clear those cells so much because this is a voting scheme, yeah? So we will put a value here, and then we will, next time we need to add additional value into accumulator, we will delete the previous one and then the next one. So for the sake of not messing everything up, yeah, at home you use the something non-permanent that you can erase with the eraser. And then at the end, you go over it with permanent pen. Okay, so this is what you would get at exam if you would write it at the university. Yeah, and now we have to solve it. Okay, so how do we solve this one? First, we have this equation of a line, okay, which is here. Okay, now what do you see in your accumulator? We have N and K here. So basically we need to turn around this equation so we have the explicit relation between rows and columns of our accumulator. Okay, so you see we have K and N here. K and N are dimensions of accumulator, and we have K and N here. So we look at this equation from a different side, because now it describes our image, because our image has dimensions X and Y. And when we are doing Hough transform, then we looked at our equation from a different perspective. We look at our equation from the perspective where X and Y are constants, yeah, and K and N are the known and unknown. Okay? So we could express either K or N, but it's more convenient to express N. You will see why, because then you don't need the division. Okay, so I will go now to this side. Oh, perfectly. So we have this equation here. So I will write this in a different color. I'll take something visible, like, yeah, green. And first thing that we do is turn around this equation. So we will say N is Y minus Kx. You see, I know this, I'm just checking it, so I don't want to make mistakes and then all over again. So this is our equation now. And now what do? We do as many steps as there are pixels in the original image. Okay? So we will have 4 steps, because we here have 4 pixels, and as we said, Hough transform is a voting scheme, yeah? So we have 4 voters that have to cast their votes. Okay? And I will say that, let's say I will draw the positions here, and I'll say like this. So this will be our number 1, which has coordinates, let's say X is 2, 2, 2, 2, will be our voter number 1. Okay? Well, okay, so you see here 2, 2 is voter number 1. Then we have another cell that is at position 4, 2, 4, 2, and this will be our voter number 2. Okay, and then we have another one, yeah, so which is the opposite, yeah, so 2, 4, which will be our voter number 3, and then we have 4, 4, which is our voter number 4, and this is X and Y position, yeah, so this is our table, yeah, of our pixels casting votes. And those pixels can, of course, split their votes, and this is exactly what we're going to do. So what I'm going to do here, I don't have whiteboard to put everything to put everything here at the same time. I will calculate these steps one by one, and we will go through each of them. Okay, so maybe the red marker would be better. Okay, so here I will start with voter number 1. Yeah, so this is how it's done. So again, those are 4 pixels. They cast votes into accumulator, and what is important, they split their votes. Yeah, so from 1 pixel you get a lots of vote in the accumulator. Yeah, that's why we do it this step by step. Okay, so we have now this one which has position 2, 2. Yeah, and let's write it down. X is 2, Y is 2. Okay, now we have this equation here, and be careful now. Now our equation actually assumes that Y and X are constants. Okay, so we'll write now equation out, and it will be N is Y here is 2 minus X is X is also 2 minus 2K. Okay, so this is our equation for the first line. Just let me check so I didn't do anything stupid. Turns out I don't have all the details. Okay, let's see. So what does it matters? How does this work? So we have N is 2 minus 2K. Good. Now if you look at this accumulator here, yeah, now we can start filling it up. We have the equation that directly relates to the accumulator. Yeah. So if we start with the lowest K, yeah, and I will explicitly draw some values. So you can see here the K values. Sorry for switching it so much, but if you see it's for some K values, here we have minus 3.5, minus 3. This is minus 2.5. Okay, these are not the lines to be ignored. It just I didn't have space to put everything in. So this is minus 3.5, minus 3, minus 2.5, minus 2, minus 1.5, and so on. Okay, so for each K, we have to calculate the corresponding N from the equation on the right side. So, and we can start here, yeah? And I'll fill this probably with a lot of equations. Just to remember where the K starts. So the first K is minus 3.5. So we have now N is 2 minus 2 times 3.5. N is 2 minus 2 point. Whoa! It's minus 3.5. Yeah, minus 3. You see? Okay. And you will soon find out that this, of course, is linear equation. So once you do a few pixels, you will see where the thing is going. Okay? So 2 times minus 3.5 is minus 7. So this is minus 7. Minus and minus gives the plus. So we have, and please correct me if I'm wrong, because this is the place where I could do a lot of mistakes. I don't have calculator with me. I really recommend using the old-fashioned calculator for this. Okay, if just to reduce the possibility that you may make really stupid mistakes. Okay, so this would be then, if I'm correct, this would be then 9. Okay? So this is then minus 6 plus 6. This would be 8. And now we have 5, this plus 5, now we have 7. You see where it's going. It's a linear equation. 2 minus 2 times, so this is 2 times 2 minus minus plus. Okay, so this is 4, this gives 6. Am I correct? If I'm not correct, please correct me so we can save some time. Okay? So 3 plus 2, it's 5. You see, at some point you don't need to write the equations anymore. So if we go back, yeah, once you have written this down, if we go back to our Hough accumulator, you can see what we will do. And maybe you know what I will do here, I will just put lines in the accumulator so it will be more visible to you. And at the end, I will convert those lines in the accumulator into scores, okay, into the number of votes. So hopefully you have this written down. I can look at it, okay? And so now let's see. Where we have minus 3.5, so this is this row, we got the end result that is 9. This is out of the accumulator, okay? If it's out of the accumulator, sorry, it's out, yeah? So we don't put it anywhere. We could put it outside, but it doesn't matter. We ignore it. Then at minus 3, we get, so for the k is minus 3, we got the accumulator position of n with 8, and this is here. So I'll draw one line here. So we have score of 1 here. Hopefully you see it. Yeah, you should see it. Okay, so it should be a red line here. Yes, I know it's poorly visible, but okay. So if we go to the next one, the next value is 7. Okay, so at minus 2.5, we have 7. Okay, 1 vote here. The next one at minus 2 is at 6. Okay, the next one, so when we calculated the position at minus 1.5, so this is minus 1, this is minus 1.5, is here, we got the value of 4. And you see where it's going. If we have lines, then you can calculate this, you can go on. If you're not sure, then go on with this, yeah, and you will see where this is going. But I can tell you that if we go like this, so if we have we'll go n of k is minus 1 will be definitely 4. Yeah, let's think. So it's, yeah, it will be 4, and n of k is minus 1.5 will be then probably 3, yeah, and so on. So I can go here and just fill the accumulator like this, okay? If I didn't make any mistake, I will just fill the accumulator here. But you have to fill it, okay? In theory, you have to solve all the equations and do it like, and do it like this, okay? Just be careful that you don't have any mistakes. Maybe we can calculate now explicitly if we did this one correctly. So n is, let's say, okay, so 3 points here. Let's calculate explicitly for if we have k of 4, which is the last row here, is so 2 minus let's say 2 minus 2 times 4, so this will be the last one, It's 2 times 4, it's 8, and so we have 2 minus 8 is minus 6, yeah? And yes, you see, my last value that I put in is this. So this is probably correct, yeah? So this is first quarter of the task, okay? So what we did here, those lines are basically for the voter number 1, okay? So voter number 1 with coordinates x is 2, and y is also 2. Now I will delete this, yeah? And we go to the another to the number 2. And number 2 has the following equation. The coordinates are x is 4 and y is 2. Okay? And of course our equation that is here now becomes n is two minus 4 times k. Okay? So this is for the voter number 2. So let's go on here and do it, yeah? So we start with n is, so the first we have minus 3.5, n is 2 minus 4 times minus 3.5. Okay, this is getting now bit more difficult, but okay, this is 2 times this is minus 7, it's minus 14. So we have 2 plus 14, which is 16, and this 16 is way out of the accumulator, yeah? You see? So if we get the n of 16s, we don't have anywhere to put it. And we can imagine, you know, when we got even, when we'll even get inside the accumulator. So let's say outside, yeah, outside. And for, let's say n is 2 minus 4 times minus 3, it will be still outside. So this is for, it's minus 12 plus, so minus 12 give it plus, so it's 12 plus 2, it's 14 outside, okay? And we won't repeat these useless calculations. We'll try to estimate where do we hit the accumulator already. And yeah, I can tell you this will be about somewhere around minus 1 or minus 2. So let's calculate the value of n is 2 minus 4 times minus 1. So what gives here? So we have plus 4 plus 2 is plus 4 plus 2 is 6. Wow, okay. So with 6 we are already inside, yeah, but we will put this inside the accumulator. And let's go a bit back. So 2 minus 4, and we have minus 1.5 is, so 4 times minus 1.5 is minus 6, and plus 2 is, so it's plus 6 plus 2 is 8. Wow, okay, so this is our boundary where do we enter the accumulator, yeah? So if we now go back, so we have for For the minus 1.5 we have 8, and for minus 1 we have 6. So let's go back to our accumulator. Yeah. So minus 1.5, this would be that row, yeah. And here we have first of our vote goes here. Then for minus 1, we get our vote in 8, you see? So, sorry, no, we get, for minus 1, we get it in 6. So this is, we skip the 7 and we land it here, okay? So you see, this is more steep curve, which is obvious because now our multiplier here is actually 4. Yeah, so you can see this will go steeper in the accumulator. And let's make another calculation for the another value of k. So n is let's say n is now 2 minus 4 times, and let's do it for minus 0.5, okay? And this would be plus 2, yeah? Minus 4 minus 0.5, so it's plus 2. Plus 2, it's 4, of course. And let's do another one, and then we will end with this voter, yeah, with this point. So we have 2 minus 4 times 0, yeah, it's of course 2. And now you can see where this is going. So we can go back to our accumulator, and for the k of 0, for the k of minus 0.5, we have our solution of n is here 4. Okay, and now for the k for the k of 0, yeah, so this is that column, we get the solution of n is 2. Wow. So now we have 2 votes here, okay? This is important. Now we have 2 votes here, and you can see we are adding votes. We added another line, you increase the score in that one. And now we can go on using the same logic, yeah, here. Don't make mistakes here, okay? So at 0.5, it should be, if you calculate, the n should be 0. So 0.5 is this, and n should be 0. So we'll put here, and for 1, it should be plus 2, minus 2. So it should be here, and then it should be here, and then it should be here, if I'm correct. And again, we can verify this for the last. So let's make the last calculation now. Yeah. So just to see if it's correct. Yeah. So we found out that the last k that fits in our accumulator would be 2. So n, so again points, n is 2 minus 4 times 2. Sorry, this is without the parentheses. 4 times 2, and what do we get? 2 minus 8 yields minus 6. And let us check what we did here. Yes, at 2 we ended up at the n is minus 6. So the second voter did its civic duty and voted for another line in the Hough accumulator. Okay, so let's go on. We have 2 more to go, but now it's getting easier. Just don't, I mean, it's getting easier because we know more, yeah? And hopefully it will be as easy for you in the exam if you get this kind of a problem, okay? So we have now our third voter, yeah, which has equation. Oh, okay. So here, which has coordinates of the pixel that at x is 4, and the y coordinate is x is 2, and sorry, x is 2, 2, and y is 4. Okay, and you will see this will be easy. Why it will be easy? Because you will see that it's basically very similar to what we did before, yeah. Because only the offset in our equation changes. So let's start as usually, and let's write the equation. Okay, so here n is, the equation will be y is 4 minus 2k, and you can immediately see that this is very similar to this one, yeah? It just has offset of 4 instead of 2, like here. So we can expect that this one will look very similar to the first line that we made. But just for the sake of teaching, let's write it out. So n, the first one is the first x, the first k with which we always start with, yeah, y. It's minus 3.5 here, yeah, it's minus 3.5, first column. So will be, according to this equation, would be 4 minus 2 times minus 3.5. Okay. This yields 4, and this is plus 7. 4 plus 7 is 11, and it's outside. We can look. There is no way that we could put 11 in the accumulator, yeah? It's outside. So next one. Now let's try to establish. So we want to just calculate for pixels that are outside. Let's try to establish where we actually hit the accumulator, and I will cheat. I'll look at my notes, and I think it is somewhere around minus 2. Let's try to do minus 2. Yeah. So n is 4 minus 2 times minus 2. What do we get? This is plus 4. Yeah, minus 2 times minus 2 is plus 4. Plus 4, it's 8. Wow. So this is the first one. Okay. So at the k of minus 2, we have 8. Wow. Okay. Again, I'll just make sure. I don't have. Did I compute this correctly? Minus 2. 4 minus 2 minus 2. It's 8. Oh, yeah. I did it correctly. I just didn't look at the... Okay. So, minus 2. We don't have anything yet. Yeah. And here goes our first vote of the voter number 3. So, minus 2. And yields n of 8. So let's go on just for 2 more values of k. So n is 4 minus 2 times, and let's say minus 2.5 will yield. So this is plus. So this is plus 5. Yeah. Here this gives us plus 5. Really? It should go to the other direction. This yields plus 5. It's not good. So minus 1.5. Yeah. So minus 2 times minus 1.5 is minus 3. So it's plus 3. So here we get 7. And yes, 7. So if we go to bit right, so now we had minus 1.5. This is minus 1.5 is this one. And here we have the result of 7. So here, 1 vote for the n is 7. One more, and then we can fill it up until the end. So n is 4 minus, and let's do for the number of 1. Yeah, this is minus 1. Sorry, minus 1. So this is then 2 plus 4 is 6. And you see the pattern, yeah? 8, 7, 6. So if we have minus 1, then we need to put somewhere in 6. So minus 1. Oh, look. Now here we have 2 votes. I'll just check if this is correctly. Yes. So we get additional vote here. And now you can see how this also goes. So now we are going like this. And I will now hazard a guess. And I'll continue this just out of I'll just speculate where this goes. Okay? So we started with 8, 7, 6, 7, 6, and now we put 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. Okay? 1 here, 1 here, 1 here. In the end, I will validate the last one. Okay? So let's say for the k of 4, what do we get? So for the k of 4, we get 4 minus 2 times 4. Okay, we don't need parentheses here. 2 times 4. It's 4 minus 8 is 4 minus 8 is minus 4. And so the last we should have, so we have for the 4, k of 4, we have minus 4. And yes, this is the last place where I put the vote for the voter number 3. Okay? So, I know it's getting boring, but this is just getting boring because you started to grasp it. Okay? So, now let's deal with the last one. Okay? Only 4 voters here, which is good. Otherwise, we would use 2 hours for this. So, I'll delete this calculation, and we'll just write down the equation for the voter number 4. So I will put it there, and this is something that will stay on. So for the number 4, we have here x is 4, y is also 4, and our equation becomes n is 4 minus 4k. Okay? And yeah, we can start with the first one, but you can see that it will start very late somewhere, yeah. So we won't even bother. We won't even bother to start at minus 3.5. Let's go somewhere in between, okay? So let's try to calculate the value if k is 0. Okay, now k is minus 1. Let's try to do it. N is 4 minus 4 times minus 1. And this yields 4 plus 4, it's 8. Okay, I cheated a bit. Okay, so at 8, so when k is minus 1, we get the value of 8. So here is our first vote. I cheated a bit because I know how this goes, okay? So I didn't just accidentally stumbled on this. So okay, let's do for the two more values. So let's say n is 4 minus 4, and let's say to minus 0.5. What we get, it's very easy. So this is then plus 2, 4, plus 2, plus 4, it yields 6. And then next one that we get is 4 minus 4 times 0, and we get 4, of course. And then the next one, 4 minus 4 times 0.5. And yes, this is 2. 4 minus 2 is 2. And yeah, it should be 2. Otherwise, you would get something strange in our accumulator. So we can proceed and try to put these votes into the accumulator. Yeah. So we started with this one. At minus 1, we got 8. Then at minus 0.5, we got 6. At minus 0.5, okay, we got 6. So one vote comes here. And then we have at minus at 0. So at 0, this is this column. We should get 4, and 4 is this. No, which is 0. Okay, this is 0, and 4. This is this. So another vote goes here. Another vote goes here. So we have 4 and 0, or 0 and 4. Yeah, and then for 0.5, which is this next column, we have the n of 2.5. We have n of 2. So this is this one. And then if we go on like this, for 1, we get 0. So one vote here. And for 0.5, we get minus 2. And then we put one here and one here, and then we out. Hopefully I did it right. Yeah. So let's look at this. Let's calculate the last one. Okay. This is the good strategy. You know, you don't need to calculate all of them, as long as you remember then lines in half space using that equation are also lines. Okay, they yield lines in the half space as well. So okay, so let's try the last one. Last one that I put in was what? 2.5. Let me see. Is 4 minus 4 times 2.5. This is 4 minus 10. 4 minus 10 is minus 6, I think. And yeah, this was the last one I put into accumulator. So this we have this here, so 2.5, and the result was -6. And yes, and we calculated our Hough accumulator. Now what we could do is now, yeah, in this Hough accumulator, the question could be, write the equations of the lines that we found. Or let's say, let's write the most probable lines that we found using this Hough transform. And what will those equations be? So let's look at the accumulator. Where is the highest value? Okay, if you look, we have no highest value than 2. And if I'm correct, we should have 4 cells with the value of 2. And then I will explicitly write the number of them. I will delete. Yeah. So here is one, number 2. Write it with a big font. So here we had 2. And here we had 2. Yeah. And here we also had 2. And here we also had 2. Okay. So if the question is find most probable line of most probable lines, what we can find out that 4 lines got the maximum number of votes. And now let's go back and think what this means. From this we can write the line equations. Okay? So I will delete what I have on the right hand side. I will delete this, and we will finalize that task simply by writing down the equations that we can get now from our finished Hough transform. You see, we don't need all of this now. Now we filled our accumulator, and we go back to basics. Yeah? So what we have here is the original equation of the line that we used. And what we have in Hough accumulator, again, remember, this is the k dimension, and this is the n dimension. Okay? So let's look, where did we get those maxima? Okay? Let's write them out. So first one, we have 4 possible lines. So let's write here 4 lines. These are top scorers, the candidates that get most of the votes in our Hough voting scheme. Okay? So, first one is, how do we get this? Look at the accumulator, and let's say, okay, this is our first winner. K is 1 and N is 0. So first one is Y is K K is 1, yeah, and N is 0. So first one is K is 1. So let's say K is 1, N is 0, which yields the equation. Look, let's use different color. Kx. Okay. The second one. Now I won't show with camera the other part. Okay, I may as well do. So the second one is here. And this one is k is, no, so the k is 0 and n is 2. Funny thing, yeah? So k is 0, n is 2, so we get, well, k is 0, n is 2, we get y is 2. Huh? You will see. We'll check if this works out. The third one is, okay, oh no, third, we have one more here. The second one is k is 0 and 1 and n is 4. K is 0 and 1 is and n is 4. Of course, I'm pretending to be surprised, yeah. So okay, so here we have the third line, and now let's the last one, because we found out that we have four maxima. So this is okay. Minus 1, k is minus 1 and n is 6. So k is minus 1 and n is 6. Woo. So this would be minus x plus 6. Okay. Now remember those lines. Okay? They look funny, you know. How did we get to y is 2 and y is 4? What are those lines? Those lines are completely horizontal, right? So the result of this Hough transform says, okay, you have the possibility of one line going in the second row and one line going into the fourth row. So if you look at our original image, wow, yeah, that's true. We have one solution that is this, right? And we have another solution that is y is 4. This is this. So we did it correctly. Now what are the other two equations that we got? Y is kx. And we all know how to draw this one, right? This goes to the origin. And so this should be, yeah. Don't be surprised. You know, y is going down, so it's a different coordinate system that you usually used to. So this line, y is kx, actually is that line. Again, bingo. This is certainly correct prediction, right? And then, of course, the second one we can just draw without thinking, minus x plus 6. That means it will go the totally opposite angle at 19-degree angles to the one that previously have. And I'll just hazard a guess and just draw it. Of course, that line goes like this through these pixels. Okay? And now you see, we did it correctly. If you would really try to, I'm just cleaning my marker. Okay, so if you would at the beginning try to manually establish, you know, which are the possible lines that could go through these 4 pixels, you would probably draw those 4, right? Now there is another question. What about 2 vertical lines? Well, the problem is, here, we actually would need, for this to be complete, the vertical lines here at x is 2 and x is 4 are also probable, right? So we are missing 2 vertical lines here. But why do we miss them? Because this equation cannot model vertical lines. So we simply cannot detect those lines, those vertical lines using the equation, and that's why in practice, in practical use, we don't use this kind of a Hough transform that we laboriously went through the, okay, almost 1 hour and a half. Okay, 1 hour and 15 minutes. So this is now the result of the Hough transform. I think everything should be crystal clear now. Okay. We have half an hour, so we can do another task. We will do some stereogeometry. So this would typically be worth, you know, there is quite a lot of work here. So this would be at the exam, you will get like, I think, something like 25% for this, yeah. So this would yield a quarter of the exam points. So this is it. Okay. Any questions regarding this? Okay, just remove about 5 seconds of latency from the YouTube stream. Okay, let's go to the next task. Although we have about, okay, let's vote. Do you want tutorial next week? We will need to do tutorial next week as well. So maybe we could arrange for about 2 to 3 hours on Tuesday. Would it be okay to you? Because I'm not sure I can finish in half an hour the next assignment. Okay, if we go deep into this like we did now. So please put your hands up and leave them on if you want me to stop now and do it next week in Tuesday. And we can do Tuesday and Wednesdays. Our exam is on Friday, if I'm correct. Okay. Huh? Ah, okay, this week. Okay. Tomorrow? So, okay, tomorrow at 10, we say? Okay, tomorrow I'll send you notification, okay? If nothing changes, we see tomorrow at 10, and we will do 3D geometry and perhaps something else, one additional task. Okay, and we finish for today. Good. Yes. Kaj pa, če pa v petek naredimo? What if do it on Friday? Let's do it on Friday, okay? Okay. Bye, thank you for watching. Ah, okay, yeah. Boom. I will. So I will collect those assignments. Yeah. I'll make screenshots out of the exam and put them into your e-classroom. Okay. So you know exactly how they're posed when you get them. Any other questions? Yes. On the exam, it will work like this. You will have to open Zoom session. Why Zoom session? Because it's too many of you for MS Teams. Okay? Zoom session, and you will have to have your camera, so the whole computer, pointed at you while you were doing the exam. Okay? So I need to see you writing an exam. So I need to see you grabbing the calculator, calculating, and so on. What you will do at the beginning, you will open your exam. It will be downloadable in PDF, and I'll try to make it this way. It will be in the single PDF landscape piece of paper, electronically speaking. So you will make it full screen in your PDF viewer. And then you'll have to have your camera on, and you have to have your microphone on. If you don't have camera, then use your phone. There is a Zoom client for Android phone. Put your connect to the Zoom session and put your phone the way that we can see you, how you are solving the exam. If you will do things that we don't consider okay, like fiddling with the computer too much, we will warn you. If your session ends, if it shuts down for any reason, then you have some time, like very short interval, to reconnect. Okay, this is the limitations, the limitation of the remote session. So one thing I propose to you is the next week we try and do this Zoom connection by everyone, and we see how does it work. Okay. So we won't have to do this on Friday, okay? I mean, we will do this as a real exam on next Friday, but I think it's beneficial for you if we just try this everything out at some point next week, okay? I will also send the email, and you can participate in testing out if you like, okay? Well, you don't have to see me, but yes, you have two screens. I cannot prevent you having two screens. The point is that I want to see if you fiddle with keyboard or mouse. If you start fiddling with keyboard or mouse, then I or Marco or Maria will warn you, because there will be us watching you on big HD screens, yeah, everyone in Zoom, and trying to see any signs of inappropriate behavior, yeah? Okay, let's do then this next week. I will invite you to the test. It's not a problem if you can't, yeah? It just, I'm offering the possibility for everyone to test out, okay? So this is then the end. Any other questions? Okay, then thank you for participating. Bye.